Hi, everyone. I think I need to get a charger. Where is it? I'm still at the conference, still with this shitty camera. Let me actually check if my audio is fine. 1, 2, 1, 2, 1, 2, 3. Well, at least audio is okay. Hopefully. So I'll close it. I don't know if it's making better or worse because it's just, too much light. So we're still waiting for Evgenia and Kasper, so they will join us soon. In the meantime, I made a post in Telegram. I'll also now add where is our stream? Here it is. I'll now edit questions. Okay, so there is the link for questions is pinned. I'll close the curtains. It's either too dark or too bright. Like there is no between. Okay, yeah, this camera looks much to be desired. Next time I buy a laptop, I hope that laptops people produce now, companies produce, they have better inbuilt camera. Because this phone, it's like, I don't know, why couldn't they just use the same camera as I have on my phone? Like, it should fit the lid of the laptop. It's weird. Anyways, so I hope my next laptop will have a better camera. So while we are waiting for Kacper and Evgenia, tell us how you're doing. How is it going so far with the course? Having fun? Today, I don't know if you watched the stream yesterday about our open source LLM Zoomcamp. So today I'm at a conference right now. So I'm not in Berlin. I'm traveling, as you can imagine. Like this is a hotel room. So I gave a workshop today about agents, and oh, Evgenia is waiting. I'm at a meeting here. So I gave a workshop today about agents, and this is something I want to include in the course too. And because, hi Evgenia, I'm just chatting. And since Kasper is also here. We are a bit delayed with the modules 3 and 4. We still need a bit of time. So I thought and everyone was asking about agents. So I thought we could use the workshop that I gave today at a conference. I'll make it as a module. I'll create it as a module. It will be a bonus module that we will use next week and week after that, I guess. While we're working on module 3 and module 4, you'll get to learn more about agents. Everyone was asking about this, so now will be your chance. So we will have an announcement. We'll have a workshop next week about that, and then based on the workshop, we'll create a module. But anyways, hi Evgenia, hi Kasper, nice to see you. I see that your camera is way better than mine. It's good because you do most of the talking, and I don't know, my built-in camera on my laptop is pretty bad.
Great. Thanks for the invite, Alexey. Really nice to see you.
Welcome. You have so many books. You're back to Krakow, right?
Yep. Yeah, actually, that's pretty common to have books in your background, right? That you just look as a smarter person than you are in reality. So
Okay.
I also follow that trend.
Set it up for
Evgenia,
videos. Unmute.
where are your books?
My books. No, Casper plays the smart one. I play the, what is it? Kind of hippie one. We balance
go
each other out.
And so what I noticed is Kacper is way louder than Evgenia. I don't know, Kacper, can you lower the microphone a little?
I think the problem is also that I put my mic somewhere there. Let me move it a little bit closer. Is it better?
Say something?
Is it better?
It's still good. Kacper, can you say something?
Yeah, how about me? No?
Okay, yeah, it's less loud. I think it's cool. So I don't know about
Great.
me. Maybe people in the comments can say if I'm shouting too loud, or like all of us have the same volume. So let us know. In the meantime, just want to briefly tell you why we are all here together on this team. So what we want to do now is we want to have office hours. So typically we have office hours, but we had office hours last year, and you can rewatch these office hours. But because this year we have new content, we have updated the vector search model, which includes Quadrant now. I thought it would be a super good idea to invite Evgeny and Kacper. Well, actually, it wasn't me, it was Valeria, our content manager. She reminded that we were doing that. So she said, okay, how about we invite them? And then I did. So here we are. All of us are now here. So I just want to briefly start with, I'll just share my screen. And this is better because my camera is pretty bad. So now at least you will not have to tolerate it. And I just want to go to our course page, LLM Zoomcamp. And I want to remind you that right now we're doing vector search model. So right now, all the questions you ask, they could be about vector search, they could be about Quadrant, they could be about related things. So ideally, it should be about this module. But if you have other questions, you can also ask, and then we see if we have time, we can answer that. If you have questions to Evgeny or Kacper, like personal, no, I mean personal, but if you want a question that specifically to Evgeny or specifically to Kacper, you can mention that in parentheses when you ask. But anyways, I think I've been talking too much. Maybe let Evgeny and Kacper introduce themselves, and then we will start the office hours.
Absolutely. Firstly, we're basically one entity. So I think, okay, maybe I'm overstating it. I think Kacper can answer more questions than I am because he is 3 times longer in Quadrant than I am. But we're both, I don't know why I started introducing both of us. Let's start with me. Okay, I can handle that. So I'm Jenny, or Evgenia, which is a longer, scarier part of the name, but I prefer Jenny actually. I am in Quadrant for already 1 year as a developer advocate. And since I have background in machine learning, so it's bachelor's and master's, I prefer to do a little bit of machine learning part of research, but as any developer advocate out of there, I'm basically a Shiva, which does everything. And I call this profession being a certified yapper. So that's what I'm doing here, yapping for money. So we'll do it today and now with pleasure. Kacper.
For money.
Absolutely.
Yeah, thank you. So, Kacper, I'm based in Poland, in Krakow. What's more, I just contributed to one of the episodes in that course about hybrid search. So, yeah, but that doesn't mean I don't know how to do semantic search without sparse vectors. So if you have any questions related to that, and since I joined Quadrant like 3 years ago, even more than this, I know the product pretty well. So if you have any questions related to the least known APIs we have, I will hopefully be able to answer them. And yeah, I'm looking forward to hear what you actually implemented with Quadrant. What are your plans? Not necessarily combined with large language models, because semantic search is ultimately not only about retrieval augmented generation, but it might be used in many other cases which are somehow not that popular, which is kind of surprising to me.
Side note,
Yeah.
I saw on LinkedIn so many super cool posts with people actually like trying out our Dash and in general, like trying to play around. And I was honestly super psyched because it was very, very nice. People went deep. So Alexey, you did amazing job of gathering a community which actually like cares to try a lot of things. It's super interesting. So I am really happy to answer some questions here from such a such an
Thank you.
experimental type of the crowd.
So I just wanted to add to what Casper said about RAG being one of the major use cases for vector search these days. So one of the first demos of Quadrant that we did together, I don't know, Casper, you probably just started at Quadrant or you're pretty fresh, right? Was 3 years ago, and back then, like nobody was really talking about RAG, and LLMs were GPT-2, I guess, was a thing, but not 3. It was interesting times. The demo is still somewhere out there on our YouTube channel. You can just look for Casper's, just put Casper's name or Quadrant, you will find this demo. Just a quick question, like Casper, to you specifically, how much Quadrant has changed since then, since we did the first demo?
Well, we are still the best in the industry, so nothing has changed actually. We just improved it a bit. But yeah, overall, yeah, as usual, we are a startup, so we are just agile company that tries to implement whatever may help our users to build even faster and better products. I'm just trying to think about, like, we definitely recorded that like 3 years ago. I'm not really sure if you remember, but actually we had two interviews. One of them was about Quadrant specifically, and we are just presenting like one idea of how to implement semantic search without any LLMs being involved. And we also had another one that was about Quaterion, which was one of our side projects. We implemented a framework for metric learning. Unfortunately, like just right after we published that, like maybe a few months later, like ChatGPT was introduced and people got excited about retrieval augmented generation. So we also had to focus on that. I'm not really sure about the numbers, but probably more than 80% of the use cases nowadays is retrieval augmented generation, but it's more than this. And yeah, you ask about what changed with Quadrant. So definitely we introduced some optimizations that were never discussed when we spoke for the last time. And there were things like binary quantization or scalar quantization that actually make it even easier to put more vectors into the same system. So you don't really need to worry that much about the memory requirements nowadays, because if you use a proper model, then you can also put like 32 times more vectors to the same machine and still experience way better performance than with just regular vectors. And many other things like our exploration API got upgraded. And also, if you already checked the notebooks we shared for the course, we also started using the query API, the universal query API, which is actually combining all the different endpoints we had in the past into a single endpoint. So right now you can also build like multi-stage retrieval pipelines, not necessarily just use a single dense embedding model, but you can also combine sparse and dense, just use sparse. So yeah, we are ultimately just expanding the number of use cases you can build with Quadrant, but it's still somehow related to some sort of vectors. We are not even trying to build like a database, because right now we can clearly state that Quadrant is a vector search engine, not a vector database. And that's something that we learned during these 3 years.
What's the difference between a vector search engine and database?
Well, there are different expectations. So you, there are these ACID properties of the databases. So there are like different expectations from the databases. So you have atomicity. You expect the operations to even like complete successfully, like fully all the operations to complete successfully or none of them. And that's something that you typically require from a regular SQL-like database, like Postgres or Oracle. And that's not true for vector databases. Like you can't have like a transaction making changes in multiple collections. Similarly, you have consistency, isolation, and durability, and those are the properties that are typically required for any database out there. And when it comes to search engines, like this is not that strict, because ultimately what you want to have is a very efficient search system. But you would never keep like the transactional data directly in the vector database due to that. It's more like to serve a completely different purpose. And the data structures that you need for efficient search are definitely different than the ones you need for regular filtering based on some attributes like we do with SQL databases. So we have a pretty interesting article about that, why you need a separate tool for search. That's also something that we did for years. Like if you are building a real production grade system, you would typically have like a keyword based system such as Elasticsearch, and you would also have like a database keeping all the transactional data. Like let's say you have an e-commerce system, you have customers, and you have products, and there are also transactions because people buy these products, hopefully. So in that scenario, I can imagine like putting vectorizing and making people searchable for some reason. Like if you want to group customers into multiple groups of interests, let's say, same for products, but semantic search over the transactions is a bit strange. Like I'm not sure.
Yeah.
I don't see like a clear use case here. So
Yeah,
that's
makes
ultimately
sense.
like a separate system. And due to the fact that it requires different means, different data structures, it's just better to keep it separate and just do not create an additional load on the existing database you have, because that's gonna break at some point if you just fire all the queries inside. This is like moving a business logic into the database.
Mhm. So PG vector, which is an extension to Postgres, would be a vector database, right? And Quadrant is vector search.
Sort of. Actually, yeah, this is like a database with vector search capabilities. It's not primarily built to support search. It is just an extension. So I have to say that I actually tested PG Vector a couple of times and I had a pretty good experience with it, but it's mostly because I didn't like put millions of vectors inside a database, and that would probably just fall short if you just scale it up. But that was totally fine if I had like thousands of embeddings. That's probably way easier to just add them directly. But if you just deal with thousands of embeddings, then you don't necessarily need any kind of search engine. You can just keep these vectors in memory and this should be fine.
Exactly.
It's more if we speak about separating search from the database, it's mostly about like higher scale systems where you really think that at some point there will be like some concurrent requests being sent to that system, or maybe like you will be dealing with lots of data and this data is like subject to change. So that's a whole difference.
And Kasper, you mentioned that you can just keep, in some cases, you can just keep your vectors in memory. And which remind me that we had this workshop, Build a Search Engine, where we show how to build a text search engine and how to build a vector search engine. It's in memory, so it's not really a vector search engine, but like it's just to understand how you do these things in practice. So you can check this out, and also you can check the homework from the last year for the vector search model, where we needed to implement it ourselves.
Yeah, that makes a lot of sense to understand that. Yeah, like I didn't know you did that, but that's a really great lesson.
Like if you really want to, like this, it doesn't really go into details of how to make it fast, because Quadrant is doing something under the hood to make it fast, to make it actually searchable. If you have like millions of vectors, you don't want to compare your vector with all the vectors in the database. You need smarter ways, which is what Quadrant is doing. But here we just do like this simple way of comparing everything with everything. But anyways, here are the questions that we have. So I think it makes sense to start with these questions. For those who haven't used it, so you go to Slido, you put LLM there, and you ask the questions. Also, there is a pinned link in the live chat. You click on that link, you ask questions. And here is the first question we have. I don't know if it's actually relevant to today's discussion. Well, I'm not really sure, but you can tell us. So how can semantic retrieval systems embed such structured common vulnerabilities and exposures data for dynamic context-aware threat intelligence? I think this question is asking, so let's say we have a use case where we have these vulnerabilities and exposures data, and somehow we want to index this data with a vector search database so we can semantically perform different searches. I don't know if you came across a use case like that. If you did, maybe you can tell us more. It's weirdly specific question, right?
Yeah. I'm just like, I don't know like any project using semantic search specifically for that. I can also imagine like two different ways of how when somebody would like to implement such a thing, like finding the vulnerability reports, like similar ones. But on the other hand, it's also, if you have like a vulnerability in your application that also traces back to the code, to the source code itself. That's a pretty interesting use case. Like, but for that you would need like a very specific embedding model that would be able to, on one hand, encode the report of the vulnerability, like the steps to reproduce, or maybe like the details of how it affects the security of the app, and on the other hand, like the source code of the application, this particular parts that were involved in that vulnerability. Like, I don't know like any model that would do it out of the box. Probably that might be done, but that would require like training the model or fine-tuning an existing model for that specific use case. But that's an interesting idea. Happy to discuss that with somebody who posted that question. Unfortunately, this is just anonymous, but feel free to just reach me on LinkedIn or Twitter if you'd like to discuss it. Unfortunately, I don't think like there will be like a model that will just give you this possibility out of the box. This is just so specialized idea.
I think there was a competition recently. Maybe it's still ongoing. I heard about it like half a year ago, maybe. The competition was you have a database with different vulnerabilities, and you have a lot of code. And the task was to use an LLM to find vulnerabilities in this. So you have description of these vulnerabilities and examples, and your task was to find this. I don't know if it finished. Maybe this person is actually taking this competition, but if you're not, maybe check it out. Maybe you'll find something. Because I think there was some work recently that, and then the reason I came across this is I was looking for some ideas for a competition, because we typically last year along the course we made a competition for LLMs. So I was looking for some ideas for this year's competition. We haven't really came up with anything yet. Probably we will, but so far we did not. And this was one of the ideas, that there was already a competition for that. So maybe you can try to find it. I don't know, Evgenia, Zhenya, do you want to add something here, or we move to the next
I
one?
pretty much agree. I can imagine the scenario where you use it for like clusterizing the vulnerabilities, like case scenarios, be it in code or like how differently represented. And also maybe you can use vector search to define anomalies somewhere. So some like data points which will be further away from clusters of your code or something, and you could inspect them. But for that, you will still need a good embedding model, say, which works with this kind of data. I sadly don't have a particular idea how does it look like, because we didn't have such a use case. But I see there is like literally second question also asking something
I think
around
it's
cybersecurity.
from the same person.
Yeah, I'm pretty sure, because they all look in line. So maybe there is a particular use case that the person is working with. So I don't think we ever stumbled upon something like that in Quadrant. I would say that vector search is good for defining like patterns in data. So it would be good to find anomalies or clusters of something, and that might help with vulnerabilities. At the same time, when we were at Berlin Buzzwords and we all were talking together, I remember we at some point discussed like how to use like private data in vector search and how to avoid having any troubles with it. And which is also kind of vulnerability of exposing something. And me and Casper, we came to the conclusion that vector search is not so good with that, because it's a little bit fuzzy. So putting guardrails is a little bit harder.
Even though you turn your data into a vector, it's still not super secure, you mean, or what?
Yeah. Like, firstly, it feels like it can be kind of back engineered. Yeah, so reverse engineer. And like, for example, if it's like private data encoded in vectors, there's maybe a way to get this private information back out of it. So I'm not sure, like, for cybersecurity, how safe vector search is in general.
So if you, what do you want to say? If you need to deal with PII information, you need to take extra measures to protect this data, right?
Absolutely. Yeah, I think so. Casper, tell me if you don't agree, because that's my impression.
Yeah, I actually remember reading like a paper that like people were trying to reverse the embeddings back to the original data, mostly for text. That was somehow successful. Like obviously, if you create the embeddings, this also works as some sort of compression. So it's never like lossless compression, but you lose some details. But yeah, I can imagine like if somebody really wants to do that, you can try to just find that like at least some approximation of the original data. So yeah, definitely some additional measures are required for that. But the
I
question is
think
also about the network traffic,
uh-huh.
which
Yeah.
is kind of interesting. Like probably I would have a look at the embedding models for time series data. I know
Yeah.
there are such models, but they're not that popular. Like majority of projects usually rely on texts. But I know there is some research, like ongoing research about time series embeddings, and that might be like really interesting to see whether it might be achieved with vector search.
A while ago, I stumbled upon a, I think it was a competition. So the goal of this competition was you have traffic, and traffic is a sequence of actions that the user made, basically logs from websites. And some of these logs were from either a bot or fraudster, I don't remember. So somebody who has, like somebody suspicious, right? So suspicious network traffic. It was labeled. One of the approaches, I think I remember they used something like word2vec, but for events data. So instead of like words, you have a sequence of words, but they use the same approach, but for creating vectors for logs. It wasn't exactly word2vec, but something similar. So yeah, maybe you can look this up and find. I'm pretty sure if you Google something like embedding for logs or something like this, embedding for events, you should find these models, the papers or competitions. Yeah.
Yeah, like also graph embeddings used to
Graph
be a
embeddings.
topic
Yeah, right.
before before we got excited with retrieval augmented generation. So I'm pretty sure there is some ongoing research. So that may also help build this up.
Mhm.
But actually, that's an interesting case. Like not that many people speak about it. Maybe we just need to discuss and have a tutorial on how to utilize some other data structures like graph time series, because that sounds like a great addition to what we have documented on our website. Like not that popular one, but maybe still interesting for many.
But to be frank, outside of that competition, I didn't hear about people using embeddings for anti-fraud cases. Perhaps there are. It would be interesting to actually, if somebody finds to discuss that. Okay. Next one. Can I think about Quadrant as an ML model for which you do training in real time and also do prediction searching in real time?
Oh, I like that one. I think yes. I think yes, because it kind of works as a simple data classifier, for example. If you're just, I mean, it's not like training, but if you add more data to it, and for example, you use the simple like nearest neighbor classification, the more data you add to it, the more precise will be the classifications because you will find some nearest neighbors around your points. The same with like anomaly detection or like deduplication use cases or any use cases where it's important to see the data points place into the vector space, and this place defines some answer for you. I personally like this use case much more than actually RAG. And also you can do metric learning on Quadrant. Casper was mentioning it. So Casper, maybe you can talk a little bit about metric learning. It's an interesting one. I love this use case.
Yeah, sure. Like well, Quadrant might be used for that just to store some references maybe, but like Quadrant itself wants to do like the training when you're
No,
looking at,
but
right?
what you can get out of it is a training data and the similarity between points. For example, like we have this distance matrix API, which is from 12th release, I think. And it's pretty handy when you need to use, for example, triplet loss to like use some spatial connection between points. And this distance matrix allows you to produce it in a convenient way for your machine learning model. So it comes in handy in a lot of machine learning tasks, I feel like.
Yeah,
It's
definitely.
cool.
That's right. Yeah, actually, that might be surprising for many, but I believe like people here know a lot of stuff about machine learning already, or at least some of you should be familiar with at least the basic methods. And yeah, actually, like I have never thought about it that way, but yeah, quadrant is actually like a KNN classifier, K nearest neighbors, actually an approximation of that. So yeah,
Yep.
this is actually a ML model
Yep.
as a service, but yeah,
Yeah.
interesting.
No, I love this one. Like this is my spot. So the person who wrote it, kudos to you. I like this one a lot.
Do you think they were asking about KNN classifier or something else?
Maybe something else. To be honest, if the person could like a little bit specify what do they mean, that would be super cool. Just in case, at least I'm not sure if Casper in the DataTalks Slack channel, I was answering a couple of questions there. So if you write a TLDR of what you meant, that would be super cool because it seems super interesting. Also, I saw there a question, how scalable is Quadrant? This is talking about the search engines use case. So yeah, Quadrant is scalable. I answered there, and now Casper added a lot to it. I hope the same person is listening.
But maybe this question is about embeddings. So for that, the embeddings that Quadrant uses, they come from like they're usually pre-trained models, right?
Yeah. We used already
It's
many.
not something that we do train in real time. So there is a model that is already pre-trained. Either you take it from Hugging Face Hub, or maybe this is something you train on your data. But there is a model that turns text or any kind of object, unstructured data into a vector, right? And then this is already pre-trained, so you don't really change this. So you train it once, and then you use it for indexing and use it for retrieval later. So this is very important that you don't change it. So in this case, training is not happening in real time. It happens before you start indexing.
Yeah, if that was the idea behind that question, that definitely, yeah. The clean embedding model is not trained if you use it.
So can I in the retrieval phase retrieve the context from different vector databases? Can I cache answer? So I think there are two questions here. In the retrieval phase, can I vector different vector databases? So the question is specifically about RAC.
Yeah, like you can. I don't really know understand why would someone
Exactly.
do that. Like you can have like multiple systems involved in retrieval. Actually, you shouldn't be thinking about retrieval as if it was just a single call to Quadrant in that case. Like if you like maybe somebody is coming from a different vector database or vector search engine actually. So there are some systems like proprietary ones that have like a free tier that allows to create you just a single collection. So in that case, I can imagine like somebody would like to use this single collection to keep the data, and then like another vector DB as a cache maybe. That doesn't make much sense in Quadrant. Like you can have multiple collections, so I don't see any reason to just combine different databases. Like if you connect to multiple systems for any, if you have to do it, like you can do it still. Like retrieval may be a very complex system. It's not only about finding the most relevant documents, but there might be some processing done on the query, on the outputs of the retrieval too. So you can actually do whatever you want. I don't see like a clear justification of why would somebody try to use multiple vector databases, but yeah, maybe there is like a valid use case that I'm
A
just not
more
unaware
common
of.
approach would be to use hybrid search. This is what you covered in the lectures. And in this case, we have a dense vector index, right? And then we have a sparse vector index, which is equivalent to text search, keyword search, right? And then what we can do is we can combine both. So this is a valid use case where you can actually, in some cases, use two different databases for that, right?
Yeah, but there is more than that. For example, if you work, let's say, with news, then you would like to prefer the news, like the most recent news. You don't want to like provide some context which is just outdated. So in that case, you can combine dense, sparse methods along with some, I like to call them business rules. So I want to prefer like content coming from the last week. So like retrieval may be very complex. We just covered like the most typical cases, but if you see that in a very specific application, it would help to add some additional processing, then just feel free to do it. Like you don't need to follow the paths that we did. This is like a really complex problem. Like, I mean, the retrieval is a really complex problem, and there are like conferences about search. So it's not that easy. But yeah, in many cases, like starting with dense embeddings and adding sparse embeddings should be a good starting point.
Danny, you want to add something, or we? There's actually like another point, but like, do you want to add something to the first part?
No, I agree fully. You can do whatever you want. Depends on what's the goals of that.
And then the other.
I feel like we're slowly inventing here agentic system or agentic RAG, which operates with several memories, which
Right.
I don't know, Alexey, maybe we should directly dive into this multi-agent scenario. Then you can use as much knowledge bases as you want.
Okay. Another part of this question, can I cache answers from a vector database into another vector database as a I think, Casper, you were referring to this, right? So let's say you have one database quadrant and then maybe another, which is Redis or whatever, which you use for caching. I don't know if it's a typical scenario, or probably most people just use quadrant directly without any intermediate.
It surprisingly it is like I still don't think like that many people do that, but that makes a lot of sense. Like if you see there are lots of repetitive questions being asked to your agents, so to say, or like if you build a chatbot, like we need to remember that if you interact with LLMs, then you pay for the tokens. And if you realize that there has been already a similar question, like the similarity of your question is very high to the ones that you have processed before, then you can cache the output of the LLM. And it doesn't only help with cost effectiveness, but it's also way faster to serve this cached response instead of just calling the LLM again. So I believe this is a very low hanging fruit, and that not that many people think about it, especially because it's not that well covered in the demos. Like demos usually follow a happy path, but this is easy to implement, so very easy win, and also helps with observability, because if you start monitoring that kind of questions you receive, then you can also, for example, detect some anomalies. Like if somebody just wants to perform prompt injection and try to use your LLM credits to, let's say, generate some structured output, because that's something what we can try to do now.
Have maybe a demo. Do you have maybe a demo of that with Quadrant somewhere, like how to cache text data?
Yeah, but probably we have like a tutorial on semantic caching. That's the term you should be searching for. But it's very simple. Like when you receive a query, you have like a special collection. Yeah, there is an article about semantic cache. So basically, when you receive a query, you create an embedding, and you always create an embedding of the query because that's what you use as an input to your retrieval. But if you just have the semantic cache layer, then you have like an additional collection that stores the output of the previous calls. So let's say you have a question that appears for the first time. You perform this whole cycle of calling the LLM maybe multiple times, and then the final response is just cached in a separate collection. So when you have another query, then you first of all try to use that query embedding to find some past interactions which were just similar. So like in that case, what is the capital of Brazil? And can you tell me the capital of Brazil? I would expect the similarity of both questions to be relatively high. So even by simple thresholding, you can find near duplicates and then decide to use the cached value instead of calling the LLM again.
And I see there is not that much code, like it's little code, right? So
No,
this is something that it seems easy to implement.
it is,
So
and
there you go.
that's a really low-hanging fruit, as already said. Like that should be like implemented way more often. And also an additional benefit of that is that if you calculate the distance of your questions to the past questions you had, you can also detect some anomalies, because like the typical spectrum of the queries you would like to handle is quite narrow, unless you build like an agent that would work with all the knowledge of the humanity. But if you work in a very specific company and you want to build a system that would be accessing your knowledge base, then if you see a question which is not relevant at all, then maybe it would also act as an anomaly detector, so you don't really handle that in any way, or maybe just include human in the loop, because maybe somebody is just trying to slick in into your system and maybe get back the prompt you sent. I don't know, like there might be different ways of how people could just use that for malicious things. So
Or
makes a lot
maybe
of sense.
somebody's just using it as a free ChatGPT, right?
Yeah. Yeah, actually, if you just go to Hugging Face spaces and if you check some of the demos there, you can probably easily find the ones which were not really protected, and then you can like ask any questions you would like, and that would ask as a free, actually like a free ChatGPT.
Yeah. Okay. Funny question. Can I get a free OpenAI key? So a key that you create in your account is free. It doesn't cost you anything to create that key. So here you go. This is a free OpenAI key.
Yeah, but you can also like try to use like I remember when I started using the agents for coding, they were able to create valid keys. I'm not telling you to do that, but that was a very very easy way to obtain a working key. But you shouldn't be doing that by any means.
Yeah. Well, actually, to be serious, when you create an account on OpenAI and you don't put any money there, you can still create a key, or you will not be able to use this key for a long time. You will quickly hit the limits, the rate limits, but still it's free, doesn't cost you anything, so you can do that. Then actually, I don't know, just put $5 there. It will be more than enough for the entire course, and even more. If you use a model like GPT-4o Mini, it really costs like fractions of cents. I have been preparing for a workshop last couple of days. Then I was doing this workshop, I was doing dry run, and when I go to my dashboard to check the costs, it shows zero. So I was using actively this model, and the price was still zero. So I was paying fractions of cents. So like, just do it. Like it doesn't cost that much, and like worst case, yeah, you just spend $5 on that. There are alternatives. So the rate limits in Anthropic models, they are less strict. So you can do more queries with Anthropic keys. Then also we have this page. Let me find it. So I think, yeah, we have this awesome LLMs link, and we have this OpenAI alternatives, and you can see like Grok, for example, it's you can use it for free. Like the limits there are pretty generous, and you can see like all the other providers that you can use for free or with little money.
Why not a llama, Alexey? I think like a llama.
Llama, yeah, also possible, but a llama is kind of, how to say, it's not the best model there, and also for those who don't have good computers, it would be difficult to actually use it. But I think I actually haven't tried the latest DeepSeek models running locally, so maybe they're actually good.
Oh, they're not bad. They're not bad.
They're not
7
bad?
billion one. If the computers like have enough resources, like 7 billion one is very good.
So did you try, Jenny?
Yeah. I built a small proof of concept example rag on it, and it was pretty decent, I would say. Like, 1 billion was like meh, but 7 billion one was chef's kiss.
Did it run on your Mac or?
Yeah, it did.
So you didn't need a GPU?
No, but like I have a pretty strong one, so it's like.
Yeah.
But yeah, no GPUs required.
So you probably have like M3 or something like this.
Mm.
Okay, cool. So yeah, if you have powerful computer, you can try that.
Yeah, but I see
for-
already another chapter about local LLMs, right? So you also mentioned some alternatives to run them locally.
Yeah.
So that's nice. I'm also a big fan of Microsoft fee models.
Mm.
They are not that good if you just ask them some random questions, but in RAG setups, they work surprisingly well. And I was able to run them on my laptop, even though that's not the best machine out there.
But probably, I suspect if you can afford a Mac that can run 7 billion model, then you probably wouldn't be asking for a free API key, right?
Yep.
Nah, it's just like how you save on costs. You don't let them.
So what is multi-vector embedding? Has it anything to do with multi-model RAG?
Okay, let me handle that one, and maybe the same time the next one, because I see two multi-model questions. So there is one thing which is multi-vector embeddings. It's basically, say you're working with your data, be it text or image or video, and you're embedding it. Usually what you are used to see is one vector. It would be, for example, for OpenAI vectors, it would be something 1,536 dimensions, as far as I remember. Multi-vector embeddings, where instead of one vector, you get actually a matrix. So several vectors encoding one object. It can be image or it can be text. There are a couple of models which are known to produce these multi-vector representations. It's Colbert for texts and Kolpali and Colquen for images. Why to use them? Because these multi-vector representations, they are very precise. So if you use them for matching, they provide much more intricacy, similarity, like intricacy-based similarity scores, because obviously if you use more vectors, you're able to encode more data from your objects, more teeny tiny details.
So
Yep.
we have this matrix, which is, I don't know, let's say 4 by 512. I just made this number up.
Yep.
It makes sense to just flatten this matrix and have an embedding which is 2000 something?
I mean, you can do that too, and some of the applications, that's how they do them, but how they do it. But in Quadrant, you can also natively store this multi-vectors as a matrix and do the max similar implementation. The differences is in how you estimate the similarity, because the similarity between this flattened vector and another flattened vector would be like you will calculate cosine or something, right? You will just,
But
it will be
what do
one
you use
score.
for matrices? Like,
And for-
wouldn't it be also like a dot product?
It will be its score, which you can look up in Quadrant. It's called maximum similarity score. So you basically compare every vector in this matrix with every vector in other matrix. You find the most matching ones. So with the maximum similarity score, for example, cosine, and then you use it for every vector in the first matrix. So for the first one, you will find the most similar one in the second matrix. For the second one, you will find the most similar in the second matrix, and so on until the vectors in the first matrix finish. You sum up all of these scores and you get the result. This allows for more fine-grained comparison, right? Because you basically look at every tiny detail in your object and you find the most tiny similar detail in the second object. How it can be used, Kolpali and Colquen are used for images, more precisely for PDFs. So it can be visually rich documents, say documents with text, charts, graphs, whatever. And instead of using OCR, so optical character recognition, where you parse all of the text out of PDF and you try to combine them with the images and yada, yada, try to do something complicated. You can just use this Kolpali-Colquen multi-vector representation models, and they will directly could be used to comparing PDF pages and finding the specific tiny information. It's Kolpali with I. Kolpali and you can do quadrant. We have a tutorial on that and a couple of blogs. I think, yeah, we have like optimizing Copali. We have a webinar. We have a tutorial which is called PDF Retrieval at Scale. So it's all about using this multi-vector models. And we also have a handful of tutorials about Colbert, which is for texts, because it's very good for re-ranking. It's a nice way of to use something that is cheaper than a cross-encoder, but more precise. Colbert. Yes. And we have like also some tutorials on that.
And I think this maximum similarity is what you mentioned, right?
Yeah, exactly. So this is about multi-vector embeddings, and you can find a lot on that because Quadrant natively supports them. Usually, like vector search solutions out there, out of all of that I know, only Vespa, I think, supported them and us. At some point, maybe somebody started extending the capability, I don't know. But yeah, it was for a long time that Quadrant supported them natively. And when it comes to multimodal, so multimodal, it's about searching through across several modalities. So for example, text to image, or image to video, or text to video. And since vector search solutions are data agnostic, they work with vectors, they work with embedding representations. Vector database is just storing the embeddings. So you just need to find a model which works with different modalities, types of data. For example, there is CLIP, which exists for a long time from OpenAPI, which handles both images and texts. So you can provide to it as an input both image and text, and it's gonna project it to the vector space where these vectors between images, like vectors of images, vectors of text, they're gonna be comparable. So for example, like an image of cat is gonna be similar to the caption, a nice cute kitten, or something like that. And
you're answering this one, right?
Yeah. So it's like multi-vector and multimodal, it's a little bit, I'm trying to separate it. So one is about how to work with multimodal data. It's about models, which just convert the representations to vectors and work with different modalities of data. And multi-vector is also specific models, but it's also specific type of representation. So it's like more matrices.
Yeah, what is interesting to me though is like the part, it's multimodal. Okay, I get it. So we have, I don't know, sounds, we have texts, we have images, we have videos, like all of that potentially can be brought to the same dimension, to the same space in which we can embed them. So we have vectors and they are comparable. But what about RAG? Like RAG doesn't really make sense here, does it? Like if we have an image, can we really do a RAG on an image?
I saw people doing RAG on PDFs once again. So
this is with this multi-vector.
Yeah. Actually, I saw people trying to do RAG on Colpali and Colcoen. Actually, also people in Germany, a couple of companies were interested in that.
Okay, cool. And one more thing. So we were on this Berlin Buzzwords conference, and there was one company which is called Superlinked. I think they use Quadrant. And what they do, so they have multimodal vectors, right? So that's multimodal, and they have it's also, they call it multimodal vectors. But what they do is they have one vector that contains, I don't know, that can contain text, and contain date, that contain, I don't know, image, whatever. Like they have multiple modalities within one vector. Some sort of like, as you have features in standard text, in standard tabular data, they have kind of feature sets or feature columns in a way in vectors. So, you know, let's say you have a long vector, but the part between 0 and 255 is responsible for, I don't know, one part. but then the next part of the vector is responsible for the other part. This is my understanding how they work, but I know they are.
Yeah. I think it's exactly how it works. They just concatenate, like you said with multi-vectors, they just concatenate it in a very, very long vector, like one of them containing all of these different modalities and types, including, as far as I remember, they also work with numbers and categorical data.
Kasper, was there anything you wanted to add to the questions I just marked as answered?
Yeah, well, maybe just one thing, that if you would like to implement multimodal RAG, then you also need to choose probably like a visual language model, VLM, not only like large language model, but a model that can accept an image as an input. And also remember, like, people were doing that already. Like, this is not that very common because people usually work with textual data, but yeah, in case you have lots of images, that makes a lot of sense.
Yeah. Okay. In domains like legal, where document context matters a lot, any advice on chunking and retrieval strategies?
I can make this answer pretty fast because we just published a blog which is called Legal Tech Builder's Guide. And it literally contains all the advices that we gave, because we are now very much interested in legal tech plus vector search. Legal tech builders guide quadrant. And I think it contains all the advices that we usually provide.
Navigating strategic decisions with vector search. Did you generate this image?
Yeah, it's the blog of my colleague, so he, as far as I know, generated it, but it's cut weirdly though. I think we need to look at it because it's supposed to have third one. Oh, okay. Nice. I spotted inconsistency. Let me solve this problem.
Okay. But yeah, here we go. So this is what. Do you cover chunking here?
Actually, I'm not sure if we covered chunking there. The thing is, I think it still depends on the use case. Like, depends on what exact type of document you work with, be it like, and depends also on the resources. So would you prefer semantic chunking or just a classical paragraph-based one? Usually people recommend just to use chunky, and I don't know, go with it. It's pretty good. I think it's called chunky.
Oh, what?
Chunky.
It's O-N-K-I-E.
Oh, that started sounding French. No, it's C-H-O-N-C.
Okay,
So all in all, it's I would say that when it comes to chunking, it's still I know that answer pieces off everybody, but it's sadly true. It works like based on your data set. You still need to experiment.
As always. So what I wanted to say is last year, you can check the projects from the last year. Some people used chunking, and you can see how they implemented this. Because in the data set we have, frankly, you don't really need chunking because documents are already good. But indeed, when you want to work with something else, usually data is not as nicely chunked as in our text. This is something we also talk about in this model project example. You can check it. I think in one of these. Chunking for longer text. You can check that. But here, basically, I just show like how you can use ChatGPT to chunk your code, because it writes some code like, oh, you can use this chunky, or what was the chunky? Could you actually spell it in chat, please? Because I'll just copy paste it. So I show that, and then you can check the projects from the last year. But also, it depends. You really need to experiment with different window sizes, with different overlaps. You need to really try it.
Yeah, if I could add something to that, like when it comes to chunking, it's not only about like dividing the text into fixed window of the same length, but it's also about bringing some additional context. Like I'm not sure about legal, like that definitely depends on the use case. But if you have some titles, that usually helps to just brings all the titles way down to the specific piece of text you would like to encode, because that already brings some more information. And also there is an interesting article from Anthropic about contextualized retrieval, contextualized chunking, which is a really great idea of how to utilize LLM so it can summarize the whole document, so you don't not only have like a very specific paragraph, let's say, but you also have this paragraph in a broader context of the whole document. So what exactly was the role of that particular chunk given the document? That's a pretty nice idea. Obviously, if you use LLM for chunking, then you can't expect to be that fast compared to this naive ways of checking. But yeah, that makes a lot of sense to use it in my opinion in many cases where quality matters a lot.
And also something we also tried last year is what you can do is you can ask an LLM to chunk your data into multiple blocks, right? So let's say you have a document which is 10 pages. You can ask an LLM, hey, can you please find sections, subsections here that make sense? So you just don't just do sliding window, but you ask an LLM to divide it into blocks, logical blocks. But at the end, what might happen is that just a usual sliding window will work better than any of these fancy things. But here you go, contextual retrieval. Check it
Yeah,
out.
it's more like a combination of both approaches. So use an LLM to provide like a longer description of the whole document, and then like the role of a particular chunk. So I feel like that might be improving the quality of the retrieval.
I guess you'll like this question, I think.
Guess what? Guess what we are gonna say?
Yeah,
The show of surprises.
yeah, like that. So what surprise us? What should
I,
be done?
I think it's very hard to ask people working in one of the companies to recommend the other one. Casper, recommend the Milvus, please. I am not doing that myself.
No, actually, like I can tell you one difference, at least from like that was a case like a few years ago when I tested Milvus. Like Quadrant requires you to run a single container, so it's relatively easy if you use Docker to just spin it up. But with Milvus, the case was that you had to run multiple containers that were communicating with each other. So that's way harder, and you definitely needed more resources to run it. But I would love to ask the second part of that question, like when should we consider between knowledge graph DB and vector DB? And actually, there was another blog post that we've published recently, like one of the companies built GraphRag on top of Quadrant and Neo4j. The company was called Letria, but if you just search for GraphRag, Neo4j, and Quadrant, then probably that should be, yeah, I think the second one, the second link. This is actually one of the examples, but if you just go to our blog, then that should be in the top of the results. That was the latest one we've published. Maybe I will just, oh, there is one, GraphRag, Howletria, the last one on the list. GraphRag, exactly this one. Yes, so this is actually an interesting case. This is pretty long, to be honest, but I worked on that together with Daniel, who wrote that. And yeah, like the company like decided to share a lot of technical details of how they implemented both systems and how they even handle the data ingestion pipeline. So that's a really great piece. I strongly recommend you to have a look. And they were actually able to build GraphRag that proves to work. It's not like a GraphRag just for the sake of doing GraphRag, but it's a proven way of how to do it properly.
We have an extra space here. Maybe, right? I think it is.
Yeah, thanks for pointing this out. You have a look.
Yeah, okay. I never really properly used Neo4j, so it's really interesting.
Yeah, but here the approach they decided to use to create like an ontology using the LLM, so that's really nice for it.
But I guess so this when we should consider between knowledge graph DB and vector DB, but since it's posted in a quadrant block it means that we don't need to choose between, like, it's not either or, it can be both, right?
Definitely, like if you want to have like semantic search capabilities, then you need some sort of embeddings. Like that's currently the only way to achieve semantic search, like using vectors. But if you just can create like a graph structure and you don't need semantic search capabilities, then probably knowledge like graph database should be just enough. That really depends on what you expect from the system. In many cases, having both helps to boost the quality because you cover multiple aspects of search.
I see that we are running out of time. Do you have time to answer this last question? I don't know,
Sure
Jenny,
thing.
Casper, who wants to go?
Absolutely. I mean, to be honest, this one requires either a lot of time or a lot of time because it's basically a big conversation about vector indexes and the classical inverted index, which is working with exact search. Well, the main difference, I would say that one is precise and exact and another one is approximate. They are built absolutely on different paradigms and on different indexes. So vector index is a very complicated data. I mean, not very complicated, depends on the vector index you're using, but it's a complicated data structure, which allows for fast search of vectors. Why it's approximate? Because vectors are very big. So it's very hard to make the search at scale exact because comparing to vectors is comparing a lot of numbers. For example, in Quadrant, we are using HNSW vector index. And you can read, and it's called high navigable small words. Each time I'm pronouncing it, it's a tone
some sort of locality sensitive hashing, or what is that?
Oh no, it's a structure. Do you know skip lists, perhaps?
Skip lists.
So there is basically such a data structure as skip lists, and HNSW was inspired by the skip lists. It's a layer of graphs. So it's a layer of nodes which are connected between these layers. We have a nice image somewhere, but I feel like if we're gonna, I absolutely can't remember in which
maybe
article.
This is the.
Oh, I know. You know,
how does vector search work in Quadrant? So
I think one of the good articles which explain the basics was in Learn, where all of our articles are. So we have these 5 sections on the top. Oh, actually, you just scroll through the HNSW picture a little bit up. Yes, here it is. Here it is. So I wouldn't say that it's the most explainable picture ever, but basically it's a layer. It's several layers of points which you build based on vectors. So it's points in the vector space and connections between them. Each layer is a graph which becomes more and more sparse the higher the level is. And this allows you to basically navigate through these layers and narrow down the search, becoming more and more precise when you go down on these layers. And so the result in the end is approximate, but this is how basically vector search scales, because if we would compare billions vectors to billions of vectors in real time, we would never get the answer, well, in any feasible amount of time. When exact search works on inverted indexes, which is basically a lookup in the long list or in the table, and you will always get the exact matches. But to go like deeper in that, I feel like it would be easier to start with some articles and maybe narrow down a little bit the detailed questions, because also HNSW is not the only index used for vector search. We prefer to use that one. We have actually a custom modification of it, which is called filterable HNSW. Other vector search solutions also use other vector search indexes, for example, EVF for some of them. And is it just a time of processing? Yeah, so the difference is that you can't make exact search on vectors at scale. It would be a very long time of processing. That's why you need INN. And which ANN is the best? Well, here I would say HNSW is kind of considered the most precise and fast, but it's very heavy to build. That's why you need certain architectural decisions to make it easy, to not easy, but feasible in production at scale, to fastly rebuild and update it when you insert, delete, update vectors. But it's considered the most precise and the fast one for the search.
And maybe what I would add is the exact search part is what we covered in the workshop that I mentioned. Again, if I go here to LLM Zoomcamp and the link build your own search engine, where it is here. So here, first we do a keyword search, and then we do a vector search. And there, it's an exact search. So we take a vector, and we have a matrix with all the other vectors, and we do matrix vector multiplication, which is the exact search. What ANN try to do is make it faster. So we don't multiply the entire matrix, but only find the relevant parts. So when I was learning about this, so I don't know this particular index, the one we covered here, but when I was learning about this, so I was learning about locality sensitive hashing, and one of the things there was random projection, LSH, which yeah, some of the vectors, I guess, some of the engines use that. So this is a fairly simple method to understand and implement. So if you want to learn more about like how these indexes work, maybe this is something you can start with, just to understand how we go from an exact search to an ANN search, and then you can try this one. So, and for me, that would be actually quite interesting. Where is it? To understand how this works. From your description, Jenny, it felt like this is some sort of, we have a tree, but it's instead of just, we have some like a decision tree where it's just one variable, we have some sort of spatial tree where we use matrices to go.
So
like
imagine like this, you have layers, and on each layer you have a graph. On the very top layer, you have a very scarce graph, just a couple of points. Then your new vector arrives. You evaluate what is the closest node of this graph to this vector in the vector space. When you find this node, you can go on one layer down when there is another graph also of connected points into the vector space, which is more precise already. So it has more nodes, and you again search like the nearest to your initial point that we're trying to find the most similar answer in our vector search engine. You again find the most similar node on this layer, and you again go down to the most precise, and then you go down until you find the most precise graph with the most amount of nodes interconnected, and then you find the most similar approximate nearest neighbor to your point. So it's basically like a path narrowing down. I remember Casper had very nice analogy with airports or traveling. Casper, could you please remind that one? It was very explanatory.
Yeah, generally, if you think about transport, like public transport, but generally transport in general, then you have like a very sparse network of all the hubs. I mean, like the biggest airports, which are well connected to each other. So whenever you try to travel to a very specific destination, then probably it's gonna work like that way. You are gonna to travel to the closest hub to the final destination. Then when you are on this hub, at this hub, you will be just trying to find like the local airports that we already like the second layer of that graph. And then when you arrive at the closest local airport to the final destination, you are gonna take, I don't know, like a taxi or a bus. But as you may tell, like the layer on the very top, like the layer of the airports, of the hub airports is very sparse. And the like the most bottom layer has like lots of connections between the points. And definitely like this approach helps you to navigate in that space way easily, because you don't really need to have a look at all the connections available.
Yeah, it feels like some sort of tree structure, but it's
sort of like probably
node.
you could also implement it as a like multiple trees. I think like
it would be interesting to see. Maybe I'll ask ChatGPT to implement this and see what it comes up with.
Oh, I'm pretty sure that ChatGPT won't be bad with it, because it sits around for some time, so different realizations. So the idea is pretty.
So this is
pretty
how
nuts.
I lately learn about new concepts. I just ask ChatGPT, hey, can you implement this in Python? And then I try to learn the code, and then I ask questions.
I honestly say, like, I think it's nice to use whatever you have.
Yeah. Okay, I think we used more time than we planned, or more of your time. Thanks, Jenny, and thanks, Kacper, for being with us today, for spending your time, for sharing your experience, your knowledge with us. Thanks a lot again for creating the content that you did. Amazing. I watched all these videos in one go, so thanks a lot for doing that. And I see people are saying thank you for amazing videos, so I join the thanks. Thanks for doing that.
Thank you. Thanks for the invitation.
Thank you very much. That was super nice.
And for everyone, we're still in the vector search module, so have fun. And there was a lot of information, so check the blog posts that we were talking about. I'm pretty sure you'll learn a lot of new things. So thanks a lot for doing this. Okay, then have a great rest of your day, and see you soon. Goodbye.
See you. Bye.
I'm trying to figure out how I